In this video, we're going to solve the linear inequality by graphing. Let's start by looking at our inequality. Y is less than or equal to negative 1/3 x minus 2. If this were an equation instead of an inequality, we would graph it using slope-intercept, which in fact is what we're going to do here as well. So notice that the minus 2 there tells us that our y-intercept is at 0, -2. And the negative 1/3 that's in front of the x tells us that our slope is negative 1/3. So we can come over to our graph and we can plot the point 0, -2 by counting down 2 from the middle. And then to find another point, we are going to count down 1 and right 3, because that is what our slope says. -1/3 is down 1, right 3. I do like to go ahead when I have a slope to plot a couple of extra points by counting down 1, right 3 a couple of times. It makes it just a little bit easier to connect those dots. Now, in order to decide, are we connecting the dots with a solid line or a dotted line, we're going to look at our inequality. Since it's less than or equal to, that bar underneath the inequality sign tells us that we have a solid line. So using a straight edge to try and make this as accurate and straight as possible, go ahead and connect those dots with a solid line. Then we're going to use a test point. We want to use any point that's not on the line. I usually pick 0, 0 because plugging in zeros are the easiest thing to plug in. We're going to plug it into the original inequality and see, is it true? So if I plug in 0 for the y and 0 for the x, I'm going to get 0 is less than or equal to -1/3 times 0 minus 2. Now -1/3 times 0 is 0. So then when I subtract the 2, I get -2. 0 is not less than or equal to -2. So this is a false statement. This means that when I'm choosing which side of my line to shade, I'm going to shade away from 0, 0. Since 0, 0, my test point, was above the line, we're going to shade below the line. And this is the solution to our inequality, because all points on the line and in the shaded area represent possible solutions to the inequality. And there we go.